Hello, welcome to this session on enlargement scale factors. We're going to look at length scale factors, area scale factors and volume scale factors. We'll start off with length scale factors. So we've got two similar shapes. It's always with similar shapes here, similar triangles. I'm going to look at the length scale factor. We first can think about it like a ratio. So from shape A to shape B, we have 8 to 20. These sides, which correspond, are 8 to 20. We can simplify that, of course. Divide it by 4, we've got 2 to 5. So you can either think about it as a ratio sides of 2 units to 5 units, or you can have a length scale factor multiplier to get from that one to that one. To A to B, you times by 5 over 2, or times by 2.5. if you prefer. 8 times 2.5 would give you 20. You could do that by doing 20 divided by 8, which is 5 over 2. So we're trying to find x. So you could do 6 times 2.5 if you wished. I'm going to think about it like this. 6, 2 to 5 is 6 to 15. Times by 3, times by 3. So it's 15 centimetres. So remember, you've always got the scale factor option or the ratio option. Find y, so there you go, y. So we know it's 2 to 5, and I'm trying to find y, and that corresponds with 25. Well, I've multiplied by 5 to get to 25. That tells me 2 times 5 is something. 2 times 5 is something. Well, what is it? 2 times 5 is 10. So this is 10 centimetres. So 2 to 5, 10 to 25. So it's 5. So it's 10 centimetres. Let's think about that a different way. Something, y times 2.5 would give you 25. So you know that something there is 10. So let's fill those in. We've got that's 10 centimetres, that's 15 centimetres. Spotting those scale factors will help you. Let's look at a problem involving area. Here we go. So we've got an area to find here. So we've got the length scale factor A to B. Well, it's going to be 4 to 6, 4 to 6, or 2 to 3. And if you think about area scale factor, we square those. So area scale factor ratio would be 2 squared to 3 squared, 4 to 9. If you were doing this using multipliers, well, you'd times 3 over 2. It's the same as multiplying by 1.5. That would be your length, but for your area, you'd multiply by 9 over 4, 3 over 2 squared, which is times 2.25, which is 1.5 squared. So we know A has an area of 28 centimetres squared, so I just need to multiply 28 by 2.25. Well, I might do this using ratio. So 28 to 28 to something is 4 to 9. Well, 4 times 7, 9 times 7, I know that's going to be 63. So that's 63 centimetres squared. 4 to 9 is the ratio of areas, so that's got to be 28 to 63. So remember, length ratios 2 to 3, 4 to 6 simplified. So the area ratio is 4 to 9, 2 squared to 3 squared. Okay, let's look at a volume problem. Here we go, volume problem. Now we've got here the length scale factor, well, 1 to 3. 8 to 24 is 1 to 3. So the volume scale factor is 1 to 27. 3 cubed. So we cube the volume scale factor. We could either say, okay, let's times 3 to get the lengths, or I could times by 3 cubed. Well, that's the same as multiplying by 27. So what is the volume of A? Well, the volume of A, you can't really see very well on the that's 25 centimetres squared there. So the volume of this is 25 times 10. That's going to be 250 centimetres cubed. So the volume of this is going to be 27 times bigger because the lengths are 3 times bigger. The volumes are going to be 27 times bigger. So 250 times 27. So let's work that out. That should give me 6750, I hope. 6750. So you're looking at 250 times 27. Just review that again. So the length scale factor was 3 times by 3, or a ratio of 1 to 3. So the volume scale factor is 1 to 27. Where did I get 27? It was 3 cubed. Okay, that was volume scale factor. We did area scale factor. Remember, we had length was 2 to 3. So area was 4 to 9. 2 squared to 3 squared. And length scale factor there, we had a ratio of 2 to 5. 8 to 20 was 2 to 5. Which was either 2 to 5 ratio, remember we could use that, or we could use the multiply by 2.5. I wanted to show you two methods, so you can choose really which one you like. Hope that's clear, thank you.